friends, welcome to Shiksharthi. In this session, we shall be discussing the zeros of a function. So let's start. Now, before discussing the zeros of a function, we should know what a function is and what are the investigative things that we would use to investigate a function, which we know by now that the basic ingredients to investigate a function are the domain and the range of the function itself. Okay, now the moment we say zeros of a function, let us try and understand this with the help of domain and range, because that is how we investigate a function preliminary. Okay, so the first point that I am discussing here is, if fx is equated to a 0, then all such values of x that we get, all such values of x here means what? The domain values. All such values of x are the domain values at which the range is 0, or the range value. The range value here refers to y or fx is 0. So the point that I'm trying to make here is, let us say that let's say that these are two different domain values that we have, which I am representing it in the form of a subscript. So x1 symbolizes one such domain value. So let's say if x1 is not equal to x2, but f of x1 is equal to f of x2, and not only equal, they are equal to a 0. In that case, both x1 and x2 will be known as the roots, and to be more precise, we will call them as real roots or zeros. Let's understand this with the help of an example, but before I go ahead, you would see that in this case also we talked about what are x1 and x2. x1 and x2 are nothing but the domain values of the function fx, for which the function fx is defined. So when we are saying x1 and x2, please try and understand that I am symbolizing it by xi now, where I know that I is equal to 1 to all such natural number values, and xi is nothing but the domain of this function f. It is nothing but the set of all the domain values of the given function f. And for all such domain values, if the range of all such values equals to a 0, that means it is nothing but these all such domain values are nothing but real roots, or another name that is given to this is zeros. And as of now, we are talking about the non-graphical presentation. So this is non-graphical. Okay, now going forward, let us understand this with the help of an example. So the example that I am taking here is, Let us say the function fx is equal to x square minus 1. Okay, and I want to equate it to a 0 to get the zeros of this function. So how do I get the zeros or the real roots of a function? When I equate the function fx to a 0, which is just like limiting the domain. Limiting the domain with the help of a fixed range, and the range is fixed to be a 0. So that is how you are limiting the domain, by making the range fixed as a 0, which is a whole number 0. Okay, now in this case, when I say x square is equal to 1, then x is equal to what? Either minus 1 or plus 1. So the point that I have already made here is, let us say if one value of x I take it as minus 1, which is not equal to the other value of x which I have taken as plus 1. But then f of x1 is equal to f of x2. So if I say what is f of minus 1, f of minus 1 will be a 0, which is 1 minus 1. Minus 1 whole square is 1, and 1 minus 1 is a 0. And at the same time, if I am taking f of x2, which in this case is f of plus 1, which will be nothing but 1 square minus 1, which is equal to a 0. So understand this point which I have already made, and here I had taken an example so that you are able to understand it better. So what are x1 and x2? x1 and x2 are nothing but the domain of the function fx, which here I had symbolized it by xi, and I here is a count of all such values. And whenever you talk about a count is always represented by a natural number. So the small n that we had taken here is a natural number. Now taking it to the next level now, and the next level is we are talking about the graphical way of understanding the same. So what is the graphical ways? We'll have to plot the Cartesian plane first. Cartesian plane is your real xy plane. Let me plot it first, and I'll take the same example that I had taken, which is x square minus 1. This is the positive side of y-axis, which we can either symbolize it by plus y or plus fx in this case. This is the negative hand of y-axis, or minus fx. This is the positive hand of x-axis, and the left hand side is the negative hand of x-axis, and this point is nothing but a 0. Okay, let me draw the graph now. So we know how to plot the graph also with the help of domain and range, which I am not discussing. So let's say this is the graph that I have plotted. The point that you need to understand here is the x-axis is also known to be y is equal to 0, because there is no space for the y coordinate on the x-axis, or we could have called it as this is nothing but fx is equal to 0. Analogously, we would have said that there is no space for x coordinate on the y-axis, so the y-axis is also known as, the equation of the y-axis is x is equal to 0. Analogously, the equation for the x-axis is either y is equal to 0, or when you talk in terms of a function, it is fx is equal to 0. Once you know this, so we know what are the zeros now. Zeros are wherever the graph of the given function fx intersects with the real x-axis. So which in this case, these are the 2 points where it intersects. And which are these 2 points? One of them is minus 1 and the other one is plus 1. So let's document it here. wherever the graph of fx intersects with the real x-axis, the real x-axis, all those domain points or domain values are nothing but all such domain values, or all those domain values are the real roots or zeros of fx. In this case, we are talking about the zeros being, this is one such intersection point and this is another such intersection point. The more you introspect on this, it becomes really interesting, and I see that function is not an unfamiliar term, because I mean, on a lighter note, we are in a habit of going for get-togethers, etc., which is nothing but a part of a function only. So if you take it on that in that perspective, I feel that the chapter or the topic like functions is really interesting, and it takes your learning to a multi-dimensional level.